In this video, we're going to look at using one-sided limits to evaluate a limit. When we say one-sided limits, we see that we have brought into play this little negative sign here and this positive sign here. They almost look like they're floating in the exponent type of space. But what they mean is this negative here, what we're talking about there is if we were looking at 7/3 on the number line and we say x approaching 7/3 to this negative here, we're talking about x approaching 7/3 from the left side. So say 7/3 is like right here on a number line, right here, and we have say 7/3. So x approaching 7/3 from the left means that we're getting larger and larger up until we hit 7/3 in this context. Now, similarly with this positive, we talk about this is going to be approaching 7/3 from the right. So since 7/3 is a positive number, when we approach this number from the right, we're going to start at numbers that are larger than 7/3 and move towards numbers that are still larger than 7/3, but they're getting less and less each time we grow up by a number. That's kind of the concept we're looking at here. But in our problem, we're told to evaluate the limits by analyzing the behavior of the numerator and the denominator as x approaches the given value. So what we're going to do is we're going to look at the numerator and denominator separately in both the approaching from the left and approaching from the right cases to see what we can come up with for our limit in general. So let's start by looking at the denominator when x approaches 7/3 from the left as well as x approaches 7/3 from the right. We see that in either case, the denominator itself is going to approach 0. But when we're approaching 7/3 from the left here, we see that we're going to be getting negative values in our denominator here, okay? Because we have values like 5/3, 6/3, going up to 7/3 that are going to leave this product here as a positive number less than 7. So we have, say, 5 or 6 minus 7. So this will still result in negative numbers. In kind of the opposite case over here, where we're going to have numbers like 9/3, which becomes 3, and then 8/3, that are going to give us a product here that's larger than 7, so this results in a kind of a positive number on the denominator here. So in both cases, let's go ahead and write that down just for our own sake. In both cases, the denominator approaches 0. Negative when x approaches 7/3 from the left, positive when x approaches 7/3 from the right. So now that we've looked at the denominators of both of these cases, let's look at what happens in the numerator, specifically of the case when x approaches 7/3 from the left. Now, we're going to start quote-unquote far from our given value of 7/3 in the left direction, say at x equals 1, and kind of move in a little bit just to illustrate something. So if we start at 1, we see that our numerator becomes 8 times 1, which is 8, minus 10, so that gives us negative 2. So we'd have a negative over a negative, which gives us something positive. But as we grow into numbers such as 6/3 and a 13/6, we kind of see that this product here becomes larger than 10, so we have something larger than 10, taking 10 away from it, so we're going to get positive numbers. And actually, as we get closer to 7/3 coming from the left direction, we're going to see that the value of our numerator up here, this is actually going to be getting closer and closer and closer to 26/3. So what we're going to get is we're going to get a positive, we're going to get values that approach positive 26/3 over some negative number as we approach 7/3 from the left. Since this denominator is negative values when x is approaching 7/3 from the left, but it's approaching 0, this implies that the limit as x approaches 7/3 from the left side is actually going to approach negative infinity. That's where we're going to be headed in that direction. And it works out very similarly for coming from the right direction, from this positive direction here. We know that as x approaches 7/3 from the right, we know that our denominator is again still approaching 0, but it's giving us positive values. And as we look at the numerator here, anything that we plug in to the right of 7/3 is going to return a positive value here. And again, it's still going to approach positive 26/3, and it's over some positive number that we have to evaluate in the denominator. But this positive number down here itself is approaching 0, kind of similarly to how we had this negative number here approaching 0. So since this is positive over positive, and it's approaching 26/3, and this is approaching 0, this implies that this limit is positive infinity. And so this is for 7/3 from the right direction, and this is x approaching 7/3 from the left direction. Now, we know from our conversations with limits that in order for a limit to exist at a certain given value here, in this case 7/3, the limit from the left has to agree with the limit from the right. And in this case, we do not have that. So we know that our limit as x approaches 7/3 of 8x minus 10 over 3x minus 7 does not exist.